complexity as a science, field of science. The second one basically dealing with questions around humanities versus the sciences. This is complexity science, the same when a physicist talks about complexity science or an economist. And number 3, basically all kinds of systems questions on applications of complexity into the system sciences, and also what is it doable. So what I thought I do is just pick some of just my personal thing, just pick a few of these cards and questions and see whether that will generate some kind of interesting conversation here in this audience. Now, one of the very interesting ones, what I will do is ask the person that wrote the question to actually explain the question. So what I have here, and I found it very fascinating, is a question from Rob Roggema. Plan the unplannable. And I don't know whether he is already in. Ah, very well. No, the reason I like your question very much is because can you design a system that will perform in a way and better than the one that you designed it for? That's a very old question from Descartes. Can you actually do that it will do better than? And that relates to complexity science. And this question from Rob Roggema is plan the unplannable. So maybe he can explain what he meant with this particular question. Can you stand up and go to a microphone or so?
Can you get my card?
That's the easy part. Go to a microphone. Go to a microphone.
Just see what I wrote down. Yeah, my idea was to plan the unplannable because in the future we don't know exactly what's going to happen, and still we need to intervene in urban systems. In my case, to actually direct or initiate change that is leading to an urban system that is increased or improved compared to the existing one. And my interest would be to couple like the more computational sciences and mathematicians, for instance, with the inventors or the designers of the city, to create a bond between those two to investigate this problem.
I think this is clear. Now,
I hope so.
Is there anyone who wants to respond to this particular question? Because if there is not much response, I will not do much about this situation.
You like the ideas.
Now, does anyone want to respond on this issue of to plan the unplannable? Yeah?
When you say better, you mean better according to what criteria? So you first need to quantify what you mean by better.
I'm not sure if we really need to quantify, but in my case, I wrote down a better city is a city that is more resilient and can anticipate for future change, even without knowing exactly what is going to happen in the future. So to create a more resilient city in that perspective. So it would mean to create urban patterns that can create a space to adjust to the future system, or to the future by adjusting them all the time. And that can be, I'm not too sure about if you really need to quantify it. I think the most interesting part is to combine different fields of science in this perspective, and to combine the quantifiable also with more quantitative aspects.
Now, I happen to know a recent paper on this topic from Bettencourt in Science. Right. And what he writes very interestingly in that paper is that you can actually approach this problem from the network point of view.
Yeah.
If you know, you can tell them. You know?
Yes, I know, and I read that paper, and I have some comments on that as well.
Please?
Because many of the research that's done on cities is looking at at explaining how the city is working and try to understand the city system. And that's, I think, only one part of the entire thing, because if you first understand how the city functions, and Bettencourt says it's functioning like a natural system.
Yeah, dual networks,
yeah,
separate
dual
networks.
networks,
Yes.
exactly. But I'm quite sure that nearly everyone understands what Barabasi told us in the morning. It's pretty well-known knowledge, I guess.
Yes, but the difference in his talk, if I can interrupt, the difference between this and that talk is that, of course, this was the optimum of the city, according to him, is due to a different kind of optimization according to different networks. One containing the food, and one is the communication with people.
Yeah.
And because the network structure is different from the two, you have a particular optimum that you can predict for a city. I think that's his story.
Yes, and that's exactly the point where that's very interesting up to then, and understanding that system and optimizing it. But then the next step would be, in my opinion, to actually intervene in that system and create something that is more evolved and better than we have now.
Thank you.
In fact, it is possible to plan for the unexpected. That is done by scenario systems, scenario training. And the misunderstanding is that most people think scenarios about what you want, what you think is likely, but it's just the things you don't want and are not likely, and then you exercise what you do in that case. What you do, what your actions are, instead of analyzing if you want it or not.
Yes, it is the
And
shell
most people
system.
make that mistake.
No, it's the shell way of doing this planning. Yes, thank you. Maybe we exhaust this topic at this moment. So let me suggest that we take a different card. And the one that also, oh yeah, I have the one here. The pistos? No, then there's a pity, because then I will have to explain what you wrote. It would be so great to also include humanities scholars, where there is also a lot of knowledge on complexity, philosophers, etc., etc. So basically the question is, should we really make the interaction between people active in humanities and between the physicists more strong? Will these two communities indeed be able to communicate in such a way between the two parties that something useful will happen? I think that many people have an opinion on this. Thank you.
Turn around. I am Gerken Hofstede and I'm a NIAS fellow. NIAS is the Netherlands Institute for Advanced Studies in the Humanities and Social Sciences. And so we have 35 or so people spending half a year or a full year together. And there are many people from linguistics or history. And you have some people who are from computer science or social sciences. I can tell you, if you didn't know it already, it is very difficult to start a talk. So I think that we should do it in the Netherlands. I think it can be very rewarding, but I would say with Mr. Jaeger, you have to select people. You have to select people who are willing to make this big step between the communities. And then it should and can work.
So do you recognize some of this interaction in the morning? Useful interaction?
I've had terrific talks. I thought the morning was very, very interesting and valuable. I couldn't say at this point whether I recognize cross-humanities, natural sciences interaction. There is a journal called Journal on Artificial Societies and Social Simulation, which was founded by a sociologist, and so they do agent-based modeling and network analysis, that kind of stuff. And recently, I think it's a Dutch girl, Nanda Weiermans, with colleagues, they did a citation analysis for that journal. No, it was somebody else. Anyway, I forget. But the result of the citation analysis was that though the people who publish in that agent-based modeling journal cite social scientists quite a bit, they are, no, Yeah, it's the other way around. Obviously, when you don't know, but I'm trying to find out whether it's still the case. But so they aren't really read by social scientists. That was the basic thing. And I have been talking with social scientists too at meetings about agent-based modeling or complexity, who tell me I don't do models, which is blatantly untrue, because everybody who is in science does models in a certain way, if only conceptual. But so there's a lot of bridge building to be done, and certainly I think that KNAW could be a partner in there. But NIAS has a lot of expertise and experience with the interface.
No, we would gladly hear more, but I have something about this story, about this point actually. There's a person called Zipf.
Yeah.
We did not hear about Zipf here. But Zipf wrote a book in 1946, and he was a humanities person. And he has an immense impact on everything we talk about here, especially the point of the fractals. What he did in the book, in the first half of the book, I read that book, is he analyzed the humanities question, if that's a humanities question, I want to know. He counted the number of words in particular texts. Now, that's, I think, a literature kind of thing. And then he asked the question, what will be the frequency of a particular word? And then he discovered that, as we saw the fractals from our first speaker, this has a fractal distribution. So the number of words are also in relation to length. So the words that are very long occur very little, and the words that are very short occur very much.
A power law distribution.
Yes.
Yeah.
So, and then he went to cities. So then he went in history, which is also humanities. He went into history, and he did the same for cities. Now, is this the kind of approach that you would like in humanities? The impact of complex science?
It would be nice if people that work in a discipline did not discount what people from other disciplines say before having listened, in a very general sense. And there are people from humanities, and there are people from exact sciences from anywhere who could take this to heart, but it's made very difficult for them because of the publish or perish incentives. This goes against taking time for listening. One of my colleagues at NIAS is a Portuguese artificial intelligence researcher, and he said, just joking during the meal, it should be forbidden to write more than one article each 5 years.
Well, that's not exactly how we feel, I think.
But in 5 years, you can actually come up with something good, right?
A book, you can write a book.
Yeah.
There you go. Thank you.
Thank you. I'm Danny Borsboom from the University of Amsterdam. I'm actually from the social sciences. I'm a psychologist, so I thought I'd jump in a little bit. And we have been doing a lot of work recently on building network models for psychopathology, where the idea is that if you develop certain symptoms, which are typically classified as mental disorder symptoms, like sleep loss, insomnia, concentration problems, these start to affect each other and form networks upon which a system can collapse into a state that we call a mental disorder. And we've been quite successful in, that's just what I want to say, in eliciting enthusiasm and interest in both the communities of the psychiatrists and in the community of clinical psychologists. And I think that was really important if you want to connect to social scientists, is that you offer a workable methodology. So that it's clear to the social scientists. You can't just come in with a model and say, here, this is a model, because that's not the way they are used to think. You need to explain how you identify the elements of a system, how you couple them, and how you study them. So I think the development of a methodology is really key if you want to build that kind of bridge.
Thank you. This, I think, is a very useful comment. Because indeed, we have a discussion, does complexity science exist? And what are the paradigmas? And what are the methods that we offer once we identify a problem as belonging to complexity science? Physicists have...
Advisors don't put any formulas in the things you tell them. They completely...
It's okay. No, but I understand what you say. We understand what you're saying. sometimes their sentences are also very complex for me. So that's the other part. No, but what you were saying was a very important thing. And indeed, in our program committee, we have a big discussion on how actually to formulate this point of method development and method use. And indeed, I think we should also remember that once we have this formulated, we should also think how to communicate this. And maybe we should just involve someone from humanities to help us to do that. So thank you very much. Yeah.
I think the best way, if you look for people in the humanities and the social sciences, especially the humanities part of it, there is a lot of people in humanities now that work with large amounts of data, with digitized historical data, digitized discursive data. And I think those are the people that you can expect to be interested in finding patterns in all these, in finding systems in all these. And probably that's a good entry point.
Excellent point. Thank you. Yes, over there.
I would just like to add one thing in addition to it being desirable to create bridges between the exact sciences, the social sciences, and the humanities. As somebody who, together with NWO, has been organizing the winter school for the NWO Complexity program for the last 3 years, I can say that I've observed firsthand that it is possible. In fact, as of yesterday, when each individual participant gave a short presentation about their research idea for the Complexity 2 program, and as I was listening to it, I couldn't tell from the way they talked about their topic what their disciplinary background was. So it is possible, and it is desirable.
And in our committee, of course, we have people from finance, from medicine, from chemistry, I'm a chemist, and physicists and mathematicians. So indeed, but it depends on people, on the willingness of people, of course, to talk in this particular way between themselves. Sorry about that. Maybe a next topic. Now, a very interesting one is this one from Mieke Verloo, Limits of Stability of the Political System. Oh, you are. Very well. Okay.
Is that predictable in complexity theory that the people that yeah, okay. I had put not more than one card, so...
Yeah, I lost your card. I made notes. In the mess, I could not...
Or can you repeat it, because I'll remember...
No, what I wrote was something like, are the limits to the stability of the political system in a democracy? Yeah. That's correct?
Because I think in political science, we tend to think, or our theories tend to predict that democracies are the most stable political system that we can have, yet we see more and more that this is not the case. So we would need to understand why it is possible that within the limits of democratic rules, within the European Union, we have countries that slide away to an authoritarian regime like Hungary. So we do not understand this at all. We have no theories. So we would need to know what are the parameters of this? What is the essential thing that is at stake there? Is it leadership? Is it Orban? Can we blame him for all this? And then what is it in the system that makes the leadership so central to it? Yeah, so there's a whole set of questions, I think, that are extremely urgent.
Is there anyone who likes to comment on the... there.
You say we have no theory. Who's we?
Political science.
Okay, because there are theories about this that have great explanatory power. I myself use national culture theory a lot, the name Hofstede, and it helps a great deal. There are other theories as well, but this is what I mean with
culture.
You need time to listen, because can national culture say anything about leadership processes, about political processes? It takes time for political scientists and others to talk, like Engelhardt, for instance, and his team have done with people that study culture. So it just takes time, but there are theories.
There are theories. I would claim they're not good theories. So I don't want to go into details about that, but you cannot claim that there is a like credible theory about political change that is based on assumptions of permanent national cultures that do not change. It's impossible that this is a credible theory.
Yeah, Roland.
I would like to add there are theories that show how it is very difficult for people not to form in-group coalitions that see one another as less deserving, and that is something that KNAW should counter with force.
I do think it's an interesting question. I just want to mention I was part of a debate in Singapore earlier this year where they've posed the question in terms of being system dependent. So Singapore clearly is an authoritarian state, and that has been extraordinarily successful for a number of decades. But a number of people realize that that top-down governance for a complex system, generally we know is a suboptimal way of running it. And they feel that the Singapore system has now transitioned to such a state of complexity that they worry about the governance model still being appropriate for the type of system that it now is. So there's a whole debate going on, which includes all the great and the good from Santa Fe and so on, in terms of what actually is the optimal governance system when you realize you have something that's technically a much more complex system. So it's a very interesting...
So I think what you do illustrate now is that from the background knowledge of complexity science, you have some insights that helped you to find your way into these difficult questions about political systems. And my question to our humanities friends, the other one, would be, do you actually believe that this helps?
Are you asking me?
Yes.
I should confess to being a biologist.
All right, now then I need to...
And what exactly are you asking me?
No, but that's fine. No, I really wanted to know is, from a political scientist, if he listens to this, whether he accepts that complexity theory will contribute something. Because that's a major issue, also in finance and other areas, of course. These are established fields. Yeah. Now, and if complexity science is claiming that they contribute something, do we accept this? And I think one of the issues with our National Science Foundation program is that we want to resolve this.
Well, accepting starts with listening. And if you don't start listening, which generally is the case between disciplines, then it becomes difficult.
No, but I accept the listening part. But now we listen. Is anyone having... Yes, please.
Sorry, this is an extremely urgent question. Because we find now in the world, in social networks and all kinds of other things, that the reaction time of original national hierarchical democracies breaks down. It's too slow. Mm-hmm. And the other side is, I have studied the last half year with the number of whistleblowers from the NSA, what went wrong in the NSA. And they have, in America, suddenly turned into a kind of tyrannical idea of having central control if they collect all the phone messages in the world, and they can't. So there's now resistance from the young hackers to make themselves invisible and organize civil society in another way that they cannot be supervised. So there's an enormous civil war coming up between governments, national governments, and their population. Sorry that I announced something which is...
No, I think it's relevant. I think
nice.
Thank you very much for this.
So we have to study that as fast as we can.
We will take account of this. So I think this topic, we still have half an hour, so I would like to touch also upon a few different topics. I have here one from an Evelien van der Herik. Aura Boucheri, is she here? This relates to individual travel patterns and the use of public transportation. So basically it is a logistics question. Now maybe someone, there you are, very well. Okay, please go ahead.
Tell about my question, you mean?
Yes, why don't you just explain it?
So, I'm fairly biased because I work in public transport. And the question is about public transport. What I see today, and I had the fortune to be in the US for a while, I see it happens there too, is that there are other ways of transport arising. There ride sharing that's investigated. In the Netherlands we've got bike sharing, which we actually see being introduced around the world. And we see that there are multiple ways of getting from A to B. And we see that not everyone is buying their own car anymore. At the same time, we see that people are interested in finding a robust way of traveling from A to B. With my group, we've been studying disruption management for a long time. It involves Leo Kroon and Professor Peter Vester in the front. But we mostly focus on how we make this public transport system efficient. How can we make this robust? But what could be an interesting question is, do these new forms of transportation, kind of informal transportation, like ride sharing and vehicle sharing, provide new ways for finding robust ways to travel from A to B? And I think this is a very complex system that we could study, because there's multiple things that go at stake. So can we work from a public transport operator or as like a big organization to see if we can make travel more resilient using these new forms of transportation?
Is anyone interested to comment on this? The real interesting question again here is, this is a logistics question, so you must have all kinds of methods from logistics that you can apply to this. Now, will complexity science add anything to that? That's really my question.
I think if you look at public transport, it's nice to think you're in control of the time. So it would be nice to think that there's some differences specifically to ride sharing. It's not likely that there will be one person. I think it's not likely we have to look at one person having all the rides. So that's like a taxi service. So I think you could say that there is some kind of other mechanism there that we don't have in control. And that's the informal part of the public transport.
But for instance, the techniques of Barabasi, would they help you to make it network science?
I think Barabasi talks about the controllability of the network and looking into what nodes are there. And I think there could be links there that we could look into. So looking at the bigger transportation network and then finding these possible nodes.
Yeah, there's someone who wants to comment on that. Please.
Basically looking at the...
Please repeat, we did not hear what you were saying.
Okay, this has to do with the idea I put in, which is about the behavior of networks in relation with the behavior of the individual. We let's say, we know a lot about, from social psychology and behavioral economics, about the behavior of the individual in the society and in the markets. And then from networks and mechanics, we know quite a lot about how networks behave. But this bridge between individual behavior and the effect on networks does far less develop than the other way around. So
now, yeah, I understand. I think what you're saying. Let me make an attempt. We heard this very interesting story about clocks, and they have the properties, but at the end, what matters is whether they can synchronize, yes or no, by having particular interactions. Now that is a very much a complexity science question, because when will it be stable and it not stable? Do we have bifurcations, that kind of thing? Is that what also would help in your question, if you would try to approach it in that particular way?
Yes, because I mean the bridge, let's say, between, because I mean, take into account intentionality and time and behavior and the individual. So it's only in the average or in the great numbers we can predict. So it's really trying to make the bridge.
Okay.
And this is the problem that you
Well, yeah, well, I think indeed you want to have a way where there's no control. If I want to, I want to have a system where I would like to use it, and I would like to use a system where I don't have to plan 3 months in advance when I travel. But we have a lot of data about the travel patterns of people, and I think it was friends of Barabasi who looked into that the travel patterns of people are actually kind of predictable. So the question is, if we look at the bigger numbers, so maybe my personal travel differs from day to day, but if I'm a group with 10 people, we could still have a flexible system enough where this would work, or where we would have several options, where maybe some days I can share a ride and some other days I'll use a bike, and I'm fine as long as I will get to my destination in time.
I think the point came across. So thank you very much. I do it because, thank you, you really did very well. But I think we also should have some different topics. Actually, this discussion reminded me of one other card, which was from Rutten, I think, or Ruttes. But it relates to the following. Suppose we have a beautiful complexity solution to a political science problem, or an energy problem, or a grid problem, or something like that, or a logistics problem that we were discussing in a second. And now we want to implement it in society. And of course there is resistance and it will not happen. So, can anyone elucidate me how we can resolve that issue? Should we work on that one in our program? Because that is, of course, a very important part. We met this particular point when we do.
And the research question would be if you can, how people can synchronize or coordinate.
Yeah.
People can
Yeah, it would be in
coordinate
that
each
sense.
other without central control, because that's usually not very good to do. So can they have a peer-to-peer network, not only as to work as a collective, but also to coordinate very fast?
Yes, I think it is very important because we had a discussion
It's called
to prepare.
distributed authority.
Yeah, so we had a discussion to prepare on this meeting with logistics people. And of course in logistics there are many ideas how to optimize particular systems. But at the end when we were talking to them seriously, they were saying, well, at the end we do not really need your ideas because practically we will not be able to implement it. So that should then be part of our program also to investigate this better. Or is some, yeah, there is some, go ahead.
There are the research from institutional economics, especially related to incentives.
Yeah.
That would certainly help
Yeah.
in
Right.
in this respect.
Right, yes. Okay, there you go. Yes?
Yeah, I think your question is too fast. So you ask, we then find solutions and then can we implement them? But if you look at, if it's a political problem, then the world is full of political interventions every day. So you can do something else first. You can first say, we found a solution, actually, how do they relate to the political interventions we are already doing? And you can maybe stop doing some of those, and that will run parallel to your solution. So I think it's not, you don't start from scratch. There is not like a world without interventions where you then suddenly have an intervention. You have a whole universe of interventions, and it's especially, I think, on the functioning of these interventions that you would need to know which of those can you stop doing. And this, to stop doing some things maybe, so you can change the balance of that maybe.
You can find the hubs, you can find the gatekeepers, they are a certain level of influence.
Okay, so if we would involve that community, then, and we would use our methods, then maybe we could make a step. I think that's what you're saying, yes. Right, yes?
Yeah, I work a lot with scenarios, and in scenarios there are 3 key golden rules. If you do things and you want people to use them, they have to be credible, they have to be legitimate, and they have to be salient. I guess what you are doing is salient because you are doing it because you think there is a problem and you need to have an answer. But to be credible, you need to raise trust, and to raise trust, you need to involve the people you are doing it for in the process. And to be legitimate is also very much related with that. So I think it's very important, the co-production.
Can I compare this trust with synchronization, or is that too quick? So that's how we would. How would we?
It's not the same thing. Trust is something. It's very fundamental. It's needed for synchronization, but it's not identical.
Because this is a very important issue. If we talk about such topics, we would like to contribute to such topics from complexity science. We have to understand the words. So that's why I was doing this. So well, I'm a chemist and physicist, so I try to relate these things, but of course that is just in a pictorial sense to something that they understand in the physics world. So it would be very useful to see what kind of models you would develop then in your context and compare them to what we are doing if you want to make an impact, I think. Would that be true? Doable?
Difficult.
Yes.
It's getting quantitative models for the softer institutional processes is difficult.
Yeah.
That's
Now-
why we should do it, right?
Yeah, absolutely.
But we shouldn't expect quick results, because as you
Not
can
in the
see in
short
this
run.
discussion, there's a lot of misunderstanding, and perhaps we need some projects to build common ground so that you explicitly allocate means to the kind of question you just asked. Can trust be seen as synchronization of whatever it is being synchronized? It's an interesting question. It merits some more thought.
Yeah, it's also interesting because you know these meetings here for complexity science in this building here from Active Science. 2 years ago there was a first meeting on this, and you know which people initiated that meeting? The sociologists, because they were perceptive of this, but they did not really understand. So, and of course they were believing that maybe if we understand, there's some use to it. And I think that's what they try to see, whether that communication is useful or not. And I think you're saying that may be. But that's all, I think, at this stage. Okay, go ahead.
I would like to throw a completely different angle to this question of can we actually implement the solutions? And because I was just reminded of a project that a colleague of mine
at the New England Complex Systems Institute is doing, where he's actually working with high school students. He's introducing complexity theory to 16-year-olds. And he's teaching them the language of complex systems. He's letting them do, small analysis, little tests. And, at this stage, these kids are not, let's say, rusted into a particular discipline. They're still open enough to see the value of it. And, if you do it with enough people, some of those are going to be the policymakers of the future. This is obviously a long-term solution. This is not going to help it overnight, but it is something worth thinking about. Is in addition to the reductionist approach, which has gotten us very far, should we complement that in our education with a more complexity science approach?
Thank you. There's a question over there.
Yes, when the issue of implementation, I'm a policy scientist, and I was of the opinion that we were already included. So let's say the policy sciences are using complexity theory to research these issues. So there is the punctuated equilibrium theory of Baumgartner and Jones, which is about agenda setting and how ideas grow and get implemented. There is transition management research at the Erasmus University. They also build largely on complex adaptive systems theory. So I would say that it could be included in the program itself.
Well, we actually intend to do this. But it was important, of course, to hear whether that view is supported. Now, you give a strong support.
Make clear in the proposal or in the call that you're looking for this implementation.
Yeah, but we should also...
Implementation is a very important issue in policy science.
Right. Well, thank you. That's a useful comment then. Yes. Now, maybe I can get back now more into the science of complexity itself. I can do that in two ways. One way I could, again, ask from the... No, let me say it in this way. When you ask a physicist about complexity, I think his basic model is turbulence of water. If you flow water through... If you have water, you flow it under a bridge. You have pillars of the bridge standing in the water starts to flow faster. You see ripples in the water behind. And then when the flow is faster and faster, you get, of course, these whirlpools. Now, that is an example of self-organization. And I think most of us, if they think, at least from my side, if we think about complexity, then it relates to systems that in principle can show that kind of behavior. And there are many complicated systems that will not show that kind of behavior. So that's not in our sense, not a complexity science problem. So that's interesting. So if you would formulate it in this way, you are going to discriminate, because then you say there are particular problems that they can try to resolve with the paradigms that they know, and they can ask the question whether in sociology or another biology or other fields, whether that model is useful, or you can ask yourself the question whether the microscopic, macroscopic relation that's behind this turbulence in the water system, whether that microscopic, macroscopic relation, which probably is very different in the social sciences, whether that will, at the end, will result in my terms, equations that result in the same behavior. Now, that is one of the questions I think we also discuss in our program committee. But what I would like to know is whether, is this a question that would also be interesting when I formulate in this way for people from political science, from biology, or from the humanities? Does it appeal? Of course, there's a way that an exact scientist would talk, but maybe not your language, I don't know. But it would give you some predictability. Because if you could make the map from your problem on such a system, then you would know what would happen. You would know the parameters. Yes, please.
I'm an economist, and we have this issue that we have a field, microeconomics, which looks at individuals, households, firms, and how they react given their set of circumstances. Yeah. And we have macroeconomics, which looks at how societies as a whole react. And the foundations of the macroeconomic models are what individuals do, but there is not a direct link between the models at the microeconomic level and the macroeconomic level. Yes. And this is something that in some cases is needed, but is extremely difficult to do.
I mean, now we talk the same terms.
Yeah,
because in our case it's also very difficult. In many cases.
It's like if you look at the question of turbulence, you can describe what water particles are doing.
But I still don't understand how it happens from the atom of the molecule. I cannot make the relation.
No.
No. So that's
same thing.
Same question. So we have something in common then. So that's interesting. So at least we have that kind of concept. Yes.
Maybe I can respond to that. There's not only microeconomics and macroeconomics, but there's also something like complexity economics. I think it is what you are asking for is being done already, and the models that are doing that are agent-based models, and this comes exactly out of complexity theory. So I think it's an example that shows where the complexity theory and the language of complexity theory also interacts with in this case with economics and finance, and I think that could also work for other fields in that way. Agent-based models is a general language, I think, that can...
Thank you, Kars. Of course, you're deep in this field from the finance point of view. We get, of course, the lecture of Lex Hoogduin later, so I thought I should not touch now on finance, because we'll get everything from you later on. But of course, that's one of the key pillars also of the program we have within the science field, is the finance part, which is in the heart of economics.
Well, the same gap is between beehive, the bees, how they behave, and the emergent behavior of the beehive, of an anthill.
Macro. It's a key point. No, okay. Maybe I should make an attempt to have a final question, and that one related to how to technically approach systems where we want to figure out whether they are complex or not. And I thought it appropriate if I ask the person who used the word atypical versus typical. Yeah, he's awake. If you can just explain what you meant by that.
So my point was that if you want to find out what the architecture is of a system that you cannot measure directly, you better look at what the system does under very extreme circumstances, because under those extreme circumstances it's going to give away what it looks like. Why? Because every system has its own unique way of being atypical. And from the atypical behavior you can judge what it is, and typical behaviors are typical systems are very similar. So this is a kind of principle that should be more general, and I'm wondering how general it actually is. Mathematically, it's very general.
No, I have to. No, I think that's a very useful remark. We know about warning systems, pre-warning systems, that kind of research also in ecology, to make stress on the systems. And when the system is in a stable situation, of course, you have an immediate response. And when you're close to this phase transition, you will have this long-term response because of fluctuation. So that kind of thing, you will figure out when you try to do this. Maybe also in interesting mathematical systems. Now, what I thought, it is now 5 minutes to 3. We will have the lectures starting in 5 minutes' time. So why should not we relax for 5 minutes? We ask the presenters to prepare their stuff. And I would like to thank everybody who contributed to this conversation, which I'm sure is very useful to our report later. Thank you.